Hi class, how are you today? We are going to do some word problems today from the same lesson that we've been doing, which is on representing linear functions. Okay, this question is number 7 in your book. This will not be in your homework. I want to use this question as a demonstration. So let's take a look at the question first. Okay, I'm going to try to zoom in a little bit. Here we are. Question number 7 on financial literacy. The amount of money Toshiko earns Y for working X hours at the library is given by the linear function y equals 10x. Find two solutions of this function. Explain each solution. Okay, you can find this question on page 393 in your book. Okay, first I want us to think about what is it really saying, okay? So it is saying that the amount of money Toshiko earns, and then it's followed by the letter Y. That means Y stands for the amount of money that he makes, okay? The amount of money Toshiko makes. And he works at the library, okay? So this is what he makes. That's the Y. And then it says that he earns for working X hours at the library. So X is the number of hours he works at the library. The function that relates the number of hours to the amount of money he makes is y equals 10x. So from here, can you guess how much money he makes per hour? That's right, it is $10. He makes $10 per hour. If you multiply that by the number of hours he works, then you will get the amount of money he makes. So this is the function that relates the number of hours to the amount of money. And then ask for two solutions of this function and then explain what each solution means. So two possible solutions. So let's say that means hypothetically, Toshiko could make, he could work a certain number of hours. What's something that's reasonable for working in a week? Let's say we want to find out how much he makes in a week. If he is a full-time worker, that means he will work 40 hours that week. So X could be 40 hours. If that's the case, what is Y? It would be 10 times 40, which would be $400. That is one possible solution. So the answer could be 400, meaning he works 40 hours to earn $400 a week. Another possible solution could be that he works only a few hours a week because he's a student and he's a part-time worker. So let's say he works only 15 hours per week. Then how much money would he make in that week? 10 times 15 is $150. So that's another solution where we relate 15 hours to $150. Okay, this is hours, this is dollars. Another possible thing we could use this equation or this function for is figure out how many hours he worked if he earned a certain amount of money. let's say he took home a lot of money this week. Let's say he earned $1,800. So if the y is 1,800, then what is x? We can equate that. 1,800 equals 10 times x, and solve for x. X would be 180. If he works 180 hours, he will make $1,800. Now, it's not possible, I think, to work that many hours in a week, so this could be his take-home pay for the month. If he makes this much money a month, that means he will have to work that many hours. And if you divide that out, it could mean that he works about 45 hours a week, which is reasonable. But at the rate of $10 an hour, he really has to work a lot just to make $1,800. But you know, that's what happens when you make minimum wage. You don't make that much money, but you are able to survive, barely. Because in the United States, things cost a lot, and $1,800 is really not very, very much. Okay, I'm going to do another question. This one is from your book. This is an example 4 from your book. And it's found right here. Example 4. Now my book looks a little different from yours because it has answers. Okay, it has these pink parts. Yours doesn't. Okay, this is from page 392. Page 392. Okay. The question says, after X hours of driving, there are Y gallons of gasoline remaining in a car. For Becca's car, this situation can be represented by 1.8x plus y equals 18. It asks 2 questions. The first one is to state the x and y intercepts and then graph the equation. So we need to first find the x-intercept and then the y-intercept. Okay, that's right here. And then they ask you to graph, so that's this. And then you're supposed to interpret what the x and y intercepts mean. Now, when they write it like this, the x with the little dash, that just means they don't want to say this twice, but it really means interpret the x-intercept. They don't write the word intercept here, but that's what they mean, okay? The x-intercept and y-intercept. Just a little, reading skill tool here there for you. Okay, I'm going to now talk about this question. Okay, so this is the question. They give you an equation, okay, and they tell you 2 things. So first they tell you an equation, 1.8x plus y equals 18. They say the situation can be represented by this function. Okay, and they tell you something in the question. They tell you that y is the gallons of gasoline that are remaining in the car. Okay, y stands for gallons of gasoline that's still in the car after driving. And then x is the number of hours, is the hours of driving that has already been done. So what they're really saying is, imagine this car. It's been driving for some time, x number of hours. It's been driving for this long. And it uses up gas, right? So therefore, it uses up some gas, okay, measured in gallons. So we don't know how much gas it uses though, okay? It doesn't say it specifically in the question, but it's actually there. And then it also tells you that it has this many gallons of gas left in the car after it's been driving for this long. And then finally, it gives you something like this in the equation. So based on what they tell you, I can see what this is really about. if this is about gallons of gasoline, then this must be gallons of gasoline as well, because you can only add gallons of gasoline together to get gallons of gasoline, right? The units have to stay the same. So if this is gallons of gas, this must be gallons of gas. Gallons of gas. 18 gallons of gas. What do you think is 18 gallons of gas? Well, that must be the amount of gas that was in the car when you started. Okay, or maybe it's what's a full tank. When the tank was still full, that's how many gallons of gas you would have. And then if you drive for this many hours, you have this much left. So what do you think is 1.8? Well, 1.8 must mean the gallon of gas that you will use per hour, because you're going to multiply it by the number of hours. So each hour you will use 1.8. So if X was 1, you will use 1.8 gallons of gas. If X was 2, you would use 3.6 gallons of gas. So 1.8 must be, okay, the amount of gas that you use per hour. Okay, measured in gallons also. Okay, so with that in mind, I know that X is what I'm going to graph on the x-axis. They tell you that. Okay, that's why they call it X. So X is going to stand for hours. So X stands for hours of driving. Y stands for gallons of gas. Okay. And we're now going to figure out the x and y intercept. That basically will say, so if I look at a graph like this, it's pretty safe to say that when I first start driving, meaning that at 0, I haven't started driving yet, I must have a full tank of gas. That's when the gas is at the maximum. And then as I drive, as time passes, the amount of gas that's in the tank is going to decrease over time. So I'm going to have a line that comes down like this. And it's going to come down at a very consistent rate, making this a linear function. So the rate that it comes down is, for every hour, I'm going to use 1.8, 1.8, 1.8, 1.8, 1.8, 1.8, okay? And I'm always going to add that to, so, and then there's always going to be some gas that's left until it's completely used up. So let's figure out what are the intercepts? What is the maximum here? And also, what is the maximum number of hours I can drive? Well, actually, I already know this part, because here in this equation, it tells me that I'm going to end up with 18 gallons of, this is how much gas I have in the tank. That's what we figured out at the beginning, the full tank. Meaning, if I did not drive, how many gallons of gasoline would remain in the car? Well, it will be 18, right? If I didn't drive at all, if X was 0, 1.8 times 0 is 0. So 0 plus y equals 18. So that means y must be 0. That's how we use these intercepts. So I'm going to use this equation to figure out the x and y intercept. Okay, when x is 0, what is y? 1.8 times 0 plus y equals 18. I just showed you this, okay? So y is equal to 18, okay? This drops out because you're multiplying by 0. So this will be my y-intercept. This is the point of 0, 18. So here, when I come to my graph, I can say, well, I'm not going to let each one of them stand for 1, because I will have to draw 18. This will go up all the way to 18. So how about each step means 2 gallons? So 2, 4, 6, 8, 10, 12, 14, 16, 18. So I barely have enough. Okay, I'm gonna barely have enough. Okay, so let's say I made this a little higher. This will be my y-intercept. It's at 18. 2, 4, 6, 8, 10, 12, 14, 16. Okay, this is what you need to do when you graph. Okay, you need to designate what each of the increments means. Here we have hours of driving. I'm going to use 1, 2, 3, 4. Okay, so let's figure out the x-intercept. Again, the same equation, but now I'm going to let my y be 0. Okay, that's how we find the x-intercept. Okay, how we find the x-intercept by letting the y be 0. So 1.8x plus 0 is 18. That means 1.8x is equal to 18. Divide both sides by 1.8. X is equal to 10. So x equals 10. X is the hours of driving, right? X stands for the hours of driving. So I'm going to use this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is going to be then my x-intercept. So now I have the two intercepts on my graph. 10 hours and 18 gallons. And then I'm going to draw a line between them. This is a linear function, so I know I should end up with a line. Okay, I connect those 2 points. Let's take a look at what this line is telling us. Let's say I drive for, how about 5.5 hours? Okay, let's say I drove for 5.5 hours. 5.5 hours. I will end up with about 8 gallons of gas. Let's see if that's true. 1.8x plus y equals 18. Okay. Let's say that the x is 5. One 1.8 times 5 plus y equals 18. Okay, 1.8 times 5 is 9. 9 plus y equals 18. Y must equal to 9. Let's see if it's true. If I go here, I can see that it's about halfway between 8 and 9. So yes, 9 would be the number of gallons of gasoline that remains in the car. Because I have driven for 5 hours, I've used up 9 gallons, I still have 9 gallons left. So this chart, this graph, can tell me how much gas I will have left in the car, you know, after driving this many hours. So gallons of gas remaining in the car, that's what, okay, the Y means. The Y stands for how much is remaining in the tank. And it's represented by this line. I can pick any point here and it will tell me that piece of information about this car. So let's say I drove for 3 hours. I hit here, right? If I drive for 3 hours, I would say I will have about 13 gallons left, around 13 gallons. Now on the graph, it's not super accurate, so we should use algebra. So if I say 1.8 times 3 hours plus y equals 18, this will give me 5.4 plus y equals 18. So y is 18 minus 5.4. which would be about 12.6. 12.6 gallons. Okay, so you can see that after driving, I get about, yeah, close to 13, around 12.6. Okay, how about another place? Let's say I drove for 8 hours. How many gallons would I have remaining? Okay, so if you go up on 8, you would hit this line here, and then you would extrapolate that here. So I would say like probably like 3.5, right? Let's see. So 1.8 times 8 hours equals 18. So this would give me 14.4 plus y equals 18. Y equals 18 minus 14.4, which is 3.6. Okay, y is 3.6. And indeed, that's about right. That's what this graph also shows, right? A little bit, here's 3, about halfway between 3 and 4. Okay, 3.6 is the exact number. Okay, so I hope this allows you to see how this is useful.